Alright, we're actually going to change this video title in your notes. It's actually called not perfect squares, but factor difference of squares. We don't need that 2 anymore either. Alright, so if you remember back to your intro video, we talked about the difference of squares pattern. So if you have two terms separated with subtraction, this is possibly a difference of squares pattern. So what we do is we check it and we say, well, those look weird. Do we square anything to get 16k squared? So you'd say, yeah, 4k times a 4k gives you 16k squared. Alright, and then what do we square to get a 1? Well, 1 squared is equal to 1. So we have two terms that we're squaring, and we are finding the difference of that. So this is a difference of squares pattern. The way that this factors, the first parenthesis is 4k plus 1. The second parenthesis is 4k minus 1. Now because you have a plus and a minus, these are not the exact same thing written twice, so we don't simplify it any further. That's our final answer, 4k plus 1, 4k minus 1. Alright, well our next example, we actually have not talked about this yet. If you have a greatest common factor, or if your two terms have any common factors that you can take out, you want to go ahead and take out a GCF before you start factoring. So I look at this and I see a 2 goes into both 16 and 2, so we can factor a 2 out. And then we have an r squared and an r, so they both have an r in common, so I'm going to take an r out with the 2. And then they both have an s. You have an s and an s cubed, but the most s's they have in common is 1s, so 2rs. Alright, if you take a 2rs out of each term, what you do is 16 divided by 2 gives you 8, so we factored a 2 out of that. If you have r squared and you take an r out, it leaves you with just an r. And then we have an s, but we factored the s out front, so there are no more s's. Then we carry down our minus sign, and then we factor a 2. We factor a 2 out from the 2, it just leaves you with a 1. We have an r, but we're factoring an r out, so there's no r's left. And then s cubed, we factor out an s, leaves you with s squared. Alright, so that's GCF factoring. And then we want to see, can we factor what we have left any further? 8r minus s squared. Is this factorable at all? Well, it's two terms with subtraction, so we want to think, is it a difference of squares pattern? Do we square anything to get an 8? No, we do not. So that's going to be the end of that thought process. We do square something to get the s squared. Oh, there's the end of the school day. We do factor an s to get an s squared, but it has to be a difference of two things that have been squared for us to keep factoring. So because we do not square anything to get an 8, this one has been factored as far as it can go.